Now, we're going to use the kinetic molecular theory to explain the differences among solids, liquids, and gases. This is our conclusion from last episode at the end of kinetic molecular theory. The differences among the solids, liquids, and gases can be explained by the relative magnitudes of kinetic and potential energy. The kinetic energy is a disruptive force. It tends to make the particles become increasingly independent. Potential energy is a cohesive force, and it tends to hold the particles stay together. Now let's look at the solid state. The solid state is a physical state characterized by a dominance of potential energy. Kinetic energy is very minimal. Particles in the solid state are drawn close together in a regular pattern by the strong cohesive forces. The potential energy is holding all the particles close to each other, stay in fixed positions. Each particle occupies a fixed position, and their movement, the so-called movement of those particles, is vibration. They cannot move away from their fixed position. They vibrate. This is a drawing to represent the particles in a solid state. And as you can see, they're very close to each other. They have minimum spaces in between, and they vibrate. As a result, solid has definite volume and definite shape. The strong cohesive forces hold the particles in fixed positions. They cannot move. That's why their shape is fixed. Their volume is fixed. It has high density because the particles are very close to each other. You have more particles in a given volume. As a result, it has high density. Because the particles are very close to each other, there's limited space for you to push them closer. So if you're pushing them closer, they start to repel each other. The repulsion starts to increase. So as a result, solid has small compressibility. Since the movement of the particles in the solid state is just vibrations, increasing temperature will simply increase the vibration, which may make the volume occupied by a particle increase a little bit, not significant. Therefore, solid has small thermal expansion. Now let's look at the liquid state. In the liquid state, the potential energy and the kinetic energy, they are comparable. They are about the same magnitude. They're comparable. No one is winning. So particles are still very close to each other. However, they have more freedom. Okay, they can move freely over one another. They cannot move away from each other, but they have some more freedom than the particles in the solid state. This is a situation, a representation of the particles in the liquid state. As you can see, the potential energy is still pretty strong, so the particles are still very close to each other. However, the kinetic energy is also comparable, so that the particles do not have to stay at the fixed positions. They have freedom to move slide over one another. They cannot still move away easily, but they have more freedom. They do not have to stay at a fixed position anymore. As a result, liquid will have definite volume. The volume will not change. The particles are very close to each other, but they have indefinite shape. The particles can flow over one another. So the attractive forces, the potential energy, are strong enough to restrict particles to movement within a definite volume. However, they are not strong enough to prevent the particles from moving over each other in a random manner. As a result, you have indefinite shape. High density, still the particles are very close to each other. As a result, you have greater amount of particles within a given volume, so still high density in liquid. Small compressibility, again, the particles are still relatively close to each other. There's very limited space in between for you to compress them. So small compressibility. Small thermal expansion, even though the particles can move freely over one another, however, the particles are still very close to each other. When you increase the temperature, the kinetic energy, the particles may move faster than before. However, it will bump into other particles quickly because all the particles are very close to each other. So as a result, the thermal expansion is limited, very small. Gas state. Gas state is a physical state characterized by a complete dominance of kinetic energy. The potential energy in gas state is considered zero. So the particles basically can move freely from each other. There is no attraction between them. They are totally independent. This is a representation of the gas state. Particles are very far away from each other. They have basically zero attraction. They move independently. As a result, for a situation like this, you'll know they will have indefinite shape, indefinite volume, low density because it's full of empty spaces in between the particles, low density, higher compressibility. There is a lot of empty space for you to press it, and relatively higher thermal expansion. Temperature goes higher, the particles move faster, they create bigger space in between them. Indefinite volume, indefinite shape, a complete control by the kinetic energy. Particles are free to travel in all directions. These particles will completely fill its container. Low density, because there's a lot of empty spaces in between particles. Large compressibility. Okay. Pressing it will decrease the space, decrease the empty space between the particles. So large compressibility. Moderate thermal expansion. The increased kinetic energy, when temperature goes higher, kinetic energy goes higher. So the increased kinetic energy enables particles to push back whatever barrier is confining them, and the volume will increase.